Now let's solve find all anagrams in a string. In this problem, we're given two strings, s and p, and we need to return an array of all the start indices of p's, anagram, and s. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So for instance, P is equal to ABC. An anagram of ABC would be BAC or CBA or ACB. We're literally creating another word by rearranging the letters of P. And so what we need to do is we need to look at our string S, and every time we have the beginning of an anagram in our string S, we need to return the index of where that anagram exists in string S. So for instance, we have ABC. The first three letters in our string S are CBA, which is an anagram of string P. So what we need to do is we need to add to an array, or more specifically a list of integers, since that's what we need to return in our solution, the index of where that anagram begins, which is at index 0. C is the first letter in our anagram. And after we account for CBA, we can look at BAE. BAE is not an anagram of string P, so we can skip it. What about AEB? Also, it's not. EBA isn't either. BAB isn't either. ABA isn't either. But BAC is an anagram of string P, so we need to add the index of B to our list of integers, which is at position 6, and we do that with the rest of our string S. So the way I'm going to solve this problem is I'm going to store all the characters of our string P into a character array, and then I'm going to sort that array, and I'll explain why I'm sorting it in just a moment. But let's just put it aside. So we created a character array that contains all the characters of our string P, and we set it aside for a bit. Then what we're going to do in a for loop that keeps looping up until we hit a character where all the characters, including that characters and after, are not of the same length as string P. So to make it make sense, let me just give an example. We have string P, which is ABC. Basically, in our loop, we're going to stop once we hit this character, because obviously we cannot form a word that has the same length of ABC, and then obviously it's not an anagram. So that's when we stop our loop. But in this loop, we're going to create an array. This array is actually going to store a certain number of characters at a time, that being the number of characters that P has, or the size of P basically. Starting at index 0, we're going to store in that array, let's say P.length is equal to X. We're going to store in our S array the first X characters. And then what we're going to do is we're also going to sort that array, because the reason why I'm sorting them is I want to compare our S array to our P array. And to do that, we're going to use the equals method found in arrays. But the problem with this function is that not only does it check if the arrays contain the same characters, it also checks for order. So if we store ABC in our P character array and we store CBA in our S character array, it's going to return false because order is relevant, and then CBA is not the same as ABC. But if we sort them, we're going to get ABC and ABC as well, so we can compare them, because we just want to check if both these arrays contain the number of characters and same characters. So if these two arrays are equal to each other, we're going to add to our list of integers the index of where the first character of our anagram in string S appears, and we can track this using the for loop, which allows us to iterate through these characters, and in the end we're just going to return that list of integers. So with that being said, let's go ahead and begin coding. We're going to first and foremost create the list of integers, which is going to store the indices of where our anagrams begin in string S. So list integer output is equal to new linked list. Then let's create our character array for our string P, which will store the characters of string P. So let's call this P array, which is equal to P.toCharacter array. And like I said, we need to sort that array. And the way we're going to do that is by using the arrays.sort method in Java to quickly just sort them out for us. So sort out P array. Now let's go ahead and write our for loop. So for int I equals to 0, we're going to first point at the very first character in our string S. Now what's the condition that we're going to loop through? Well, what we're going to do is we're going to check if I plus P dot length is less than or equal to S dot length, I plus plus. So let's make sense of this. If we're looking at this character, which has an index of 8, and we add to it the length of p, which is 3, we're going to get 11, but the size of string s is 10, and since 11 is not less than or equal to 11, we're going to exit our for loop. If we were looking at a, which has an index of 7, 7 plus 3 is 10, so 10 is less than or equal to 10, which is the size of our string s, and we actually account for this a, and we actually are going to check the character that we're looking at index 7 and the other two characters in our string s. So to summarize, I plus p dot length makes sure that the character which we're currently on has enough characters in front of it to be compared to string p. Otherwise, we cannot form an anagram where one substring has less characters than our string p. So now we're actually going to create our other character array to store the X amount of characters that we're, I guess, investigating. And so we can call this S array. Now what S array is going to be is, first of all, we're going to look at our string p, find out its length, because we're only going to compare that length of characters in our string s to our string p. And what we're going to do is we're going to create a substring of our string s, which are going to be the characters that we're going to compare. And then we're going to turn that substring into a character array, which we're then going to store in S array. Now for every loop, that substring is going to be, like I said earlier, if p has a length of x, then our substring is going to be x characters relative to index I. So if index I is 0, which looks at the first character in string, then we're going to create a substring that contains this character and the other x characters, or rather x minus 1 characters. So in this example, p is equal to 3. We're going to create a substring of cba, which has 3 characters. And then after our loop, we're going to increment I and look at b, and we're going to create a substring of 3 characters, which then would be bae, and then so on and so forth. And the way we're going to do that is we're going to s dot substring starting at index I. Index I, or the character at index I, is included up until the character at index I plus p dot length. Now the character that this index is pointing at is actually excluded. So once again, going back to this example, p dot length is equal to 3, and our index I, let's say it starts at 0. We're going to include the character that index I at 0 is looking at, which is c, and we're going to stop at I plus 3, which is 3. So that's 0, 1, 2, 3. So once we hit E, we're going to form a substring of the characters before it, excluding E. And then with that substring, we're just going to turn it into a character array so we can store it in our S array. Once again, we're going to call our arrays.sort to sort our array, because now what we're going to do is we're going to compare our arrays. So arrays.equals, what are we comparing? We're comparing the p array to the s array, and if this returns true and they're equal, then output, which is the list of integers that we created, we're going to add to it the index I, which we're on, which would be the index of the first character of our anagram. So finally, I can return output and submit the code and see if it works. Very minor typo, forgot the bracket here. Awesome. So that was the find all anagrams in a string problem on LeetCode. It's not the most efficient because we are constantly creating substrings after each index, and we're also using the arrays.sort method, which has a time complexity of n log of n, or o n log of n. So it's not the most efficient solution, but it works, and that's all that matters. So I hope you found that video helpful, and thanks for watching.